Alright guys, so welcome back to another tutorial series, and this time is about a particular topic. Is related to optimization, but basically about getting branchless code. Alright, so recently I had to create a function that basically, given barycentric coordinate inside a triangle, I need to compute an offset right inside this triangle, and the idea was to push toward the coordinate with the lowest value, right? So in this way, no matter where I am in the triangle, I'm always going to push inside the triangle, right? If I push with a fixed amount, I will need to handle all the boundary cases where I get outside the triangle doing this and not getting out. This means I need to find the lowest coordinate and push accordingly, right? So here is really naive implementation, right? So offset UVs, I get the UV as an input and I write out the offset UVs, right? So basically what I do is check, is the U the lowest one? And basically I'm going to offset that accordingly. This code is not really particularly important, but basically I'm giving the offset to the correct one and I'm subtracting half the offset on the other coordinate, right? In this case only V, because W is computed on the fly, right? So it's not actually stored. I do the same for V if V is the -1. Otherwise, the implicit case left is that W is the biggest, the smallest one. So I'm basically subtracting from both U and V. So as you can see, I have a couple of branches here, and since there's a function inside a tiled loop that was going to be executed a lot, I really didn't feel comfortable in having all these branches. Also because the processor has no way to predict, or neither the compiler for that matter, the value of U and V, so try to have any kind of branch prediction, right? So this value is going to be all over the place, so you have no idea which branch you're going to take. So pretty much branch prediction is useless, and most likely you're going to stall the pipeline a lot, which is bad. So what I tried to do was to see, all right, let's see if I write a branchless function, right? What am I going to get, right? I'm going to get any speed boost, any performance improvement, how complex it's going to be, and so on. So without further ado, I have a small benchmark running the naive function and two different implementation of a branchless function, right? And see what we actually get. So there we go. So the first implementation of branchless is like 5% faster. The second one is 22% faster, right? And if a run is fairly consistent, as it should, so 5%, 22%, all right? So this was just the introductory videos, right? So basically I wanted to explain the problem, see the naive implementation of that, right? And next, in the next two videos, we're going to see the first improvement, the 5% one, and then a 22% one. All right? So see you in the next video, guys.